In a stunning revelation that may reshape our understanding of our place in the universe, NASA has announced the detection of what appears to be the first extraterrestrial signals coming from the direction of Proxima b. This exoplanet, located just over 4 light-years away, orbits within the habitable zone of its star, Proxima Centauri, the closest star to our solar system. The news has sparked a surge of excitement and global curiosity. Could this finally be the moment when humanity confirms it is not alone in the cosmos? This groundbreaking development didn't happen overnight. It was the result of years of meticulous observation by NASA's advanced telescopes, which have been tirelessly scanning distant stars and planets for potential signs of life. Among these targets, Proxima b has long stood out due to its Earth-like characteristics and its proximity to Earth, making it a prime candidate in the search for intelligent life. The signal detected from its direction is unique and unlike anything astronomers have encountered before, possibly signifying a major turning point in our species' history. The implications are staggering. First, this discovery may provide direct support for the long-held scientific theory that life could exist elsewhere under similar conditions to Earth. But more importantly, it raises fascinating questions about what kind of beings, if any, might inhabit Proxima b. Are they simple life forms or advanced intelligences capable of sending interstellar messages and possibly even traveling between stars? What sets this signal apart is its structure. It's not just background cosmic noise or a natural anomaly. Instead, it exhibits a consistent, repeated pattern that hints at an intelligent source. NASA's scientists, along with teams of international researchers, are now focusing their efforts on decoding the message to determine its content and purpose. The global scientific community is buzzing with hypotheses. Some believe the message could be a greeting, a guide, or even a warning, while others admit it may be something we cannot yet comprehend. This discovery has spilled out from the world of science and into public consciousness. People everywhere are talking about it, from posts on social media to serious discussions in governmental circles and over dinner tables. There's a renewed sense of wonder as people look up at the night sky, imagining others doing the same from a world light years away. Questions abound. How similar is their planet to ours? What kind of society might they have? Could their technology and culture be vastly ahead of ours, or entirely unrecognizable? Beyond curiosity, the detection raises deeper ethical and philosophical dilemmas. If this really is a message from intelligent extraterrestrials, how should humanity respond? Do we even have a protocol for initiating interstellar communication or diplomacy? And even more significantly, how would this reshape our understanding of religion, existence, and our identity as a species? Despite the excitement, scientists are approaching the signal with careful skepticism. NASA and other leading space agencies are rigorously analyzing the data to eliminate the possibility of error or misinterpretation. The stakes are enormous, and every step must be taken with precision. As the world waits for confirmation and further analysis, this could very well mark the beginning of a new era in science and human self-awareness. The signal in question was actually detected back in April 2019, originating from the direction of Proxima Centauri, roughly 437 light-years away. Though that distance might seem vast, it's our cosmic next-door neighbor, and much closer than many other stars we observe. Proxima Centauri is part of a triple star system that includes Alpha Centauri A and B, both of which are relatively similar to our Sun. Alpha Centauri A shines with a yellow light and is about 1.5 times brighter than the Sun, while Alpha Centauri B glows orange and is about half as bright. Our own Sun fits in size between these two stars, but what about the signal itself? It was detected by the Breakthrough Listen project, an initiative dedicated to scanning the universe for signs of extraterrestrial communication. With nearly $100 million in funding, the project has used some of the most advanced radio telescopes available. The Parkes Radio Telescope in New South Wales, Australia, made the discovery during observations focused on the Proxima Centauri system. Finding the signal was no easy task. The telescope gathered vast amounts of data, millions of individual radio signals. From this enormous data set, scientists carefully filtered out the background noise. Eventually, they narrowed it down to around 5,000 noteworthy signals. Among these, one stood out. This particular signal had no known earthly origin and displayed two key traits. It was confined to a narrow frequency band, something natural sources rarely produce, and it varied in a way that matched the relative movement of an exoplanet like Proxima b. The signal appeared only when the telescope was directed at Proxima Centauri and was observed consistently over a 30-hour window. After cross-referencing with terrestrial transmitters and running in-depth analysis, researchers traced it back to Proxima b, an exoplanet discovered in 2016 using the radial velocity method. This technique tracks subtle shifts in a star's light spectrum caused by the gravitational tug of orbiting planets. These changes appear as tiny, repetitive shifts between red and blue light, which can signal the presence of a planet. Proxima b is remarkably similar to Earth in several key ways. Its radius is about 1.1 times that of Earth, and its mass is 1.3 times greater, indicating a rocky surface with a similar density. However, it also differs significantly. Proxima b is located much closer to its star than Earth is to the Sun, only about 0.05 astronomical units away, compared to Mercury's 0.39 AU distance. Despite this closeness, the planet may not be scorching hot because Proxima Centauri is a dim red dwarf star. As a result, the planet receives only about 60% of the energy that Earth does from the Sun, placing it potentially within the habitable zone where conditions might support life. Our universe is filled with countless other exoplanets. So far, astronomers have confirmed the existence of approximately 4,935 of them, and that number recently grew by another 65 planets added to NASA's Exoplanet Archive. This milestone, achieved on March 21st, marks a new chapter in our exploration of distant worlds. The James Webb Space Telescope, the most powerful telescope ever built, plays a crucial role in this mission. It's 100 times more powerful than its predecessor and is designed to help scientists uncover the secrets of the universe, including the potential for life on other planets. Webb has already expanded our knowledge of everything, from massive gas giants to rocky, Earth-like worlds. Among the promising discoveries is Kepler 1649c, a planet that closely resembles Earth and is currently considered the most potentially habitable planet discovered to date. In total, scientists have identified 55 Earth-like planets, though not all have been studied in detail. With continued advancements in space technology, especially through tools like Webb, the possibilities for future discoveries are virtually limitless. One of Webb's main goals is to study planets beyond our solar system to determine how they form and whether they might contain water or even life. Its unique infrared capabilities allow it to see through dense clouds of dust, up to 20 times thicker than what visible light can penetrate. This is essential for studying young stars and planetary systems as they are forming. Infrared light also reveals thermal signatures and the presence of vital chemical components such as water and organic molecules. Webb's observations help scientists trace the early stages of star and planet formation, when gas and dust are still collapsing, into young stars and planets. Both young stars and giant planets emit more light in the infrared spectrum, which makes Webb the ideal instrument for capturing these hidden moments of cosmic birth. Its MIRI instrument is also designed to search for hot molecular gas around young stars, a sign that rocky, potentially habitable planets may be forming. In the coming years, much of Webb's scientific work will be dedicated to answering one of the most profound questions we've ever asked. How did planetary systems build the molecules necessary for life? By linking the